In the rectangular coordinate system, are the points RS and UV equidistant from the origin? So statement number 1 tells us that R plus S equals 1. Well, first of all, there's an infinite number of possibilities for what R and S can be, but more to the point, this statement gives us no information about UV. And because we have absolutely no clue where UV is, we have no way of determining at all whether it is equidistant from the origin as RS. So this statement by itself is woefully insufficient. So forget about that. Focus purely on statement number 2. Statement number 2 tells us that U equals 1 minus R and V equals 1 minus S. Another way to write those, incidentally, is that R plus U equals 1 or S plus V equals 1. Well, this is interesting. This presents us with a bit of a puzzle. Well, we notice, for example, I notice that if RS is the point 1/2, 1/2, well, then that would necessarily mean that UV is also the point 1/2, 1/2, and of course those would be the same points, so they would be equidistant from the origin, so the answer would be yes. But if I pick the point RS equals 1, 1, well then that would mean that UV equals 0, 0. And 0, 0 of course is at the origin, and 1, 1 is not at the origin, so these points are not equidistant from the origin. So that would give an answer of no. And so it means that different values that I could pick will give different answers to the question. And right there, that's a sign that the information you have is insufficient. So statement number 1 and statement number 2, both insufficient. Now if we combine them, some very clever algebra happens here. We combine them, we know that R plus S equals 1. We also know that R plus U equals 1. And what this means, what that tells us, is that S must equal U. Similarly, we have R plus S equals 1, and S plus V equals 1. I'm going to write that as V plus S equals 1. Well, that tells us that R equals V. And so the x-coordinate of the first point is the y-coordinate of the second point, and the y-coordinate of the first point is the x-coordinate of the second point. So it means that if RS is a point, say, like 3, 4, then UV would have to be a point 4, 3. Well, such a point is a reflection over the line y equals x, but such a point is always going to have exactly the same distance from the origin, because if you go out an x distance of 3 and then a y distance of 4, that's going to put you the same distance away from the origin as if you go out an x distance of 4 and then a y distance of 3. It's just basically geometrically it's the same triangle rotated, but the hypotenuse would still be the same. So this statement by itself is sufficient. Both individual statements are insufficient. The combined statement is sufficient. Answer choice C.